Hello, my name is Sandra Martin and this is my YouTube channel. In this video, we're talking about two main things. One, why does the data path cycle have a huge influence on the performance of CPU? Two, how does the CPU fetch, decode, and execute instruction? First of all, what is data path cycle? Data path cycle is the fetch, decode, execute cycle, which the data path implements in a processor. The data path is the part of the processor that carries out the instructions and is made up of several components, including memory, which stores the current instructions, program counter PC, which stores the address of the current instruction, arithmetic logic unit ALU, which executes the current instruction, registers, which are the small, high-speed storage elements that temporarily store data while it is being processed. Bus, a communication system that transfers data between components of a computer or between computers. Multiplexers, select data from multiple sources and route it to the appropriate destination. Next is the importance of data path cycle. The data path cycle is important because it improves a computer's overall performance by ensuring the data moves efficiently and smoothly through the system. Below are some importance of the data path cycle. 1. Data transfer. A well-optimized data path reduces bottlenecks and allows for faster data transfer, leading to quicker task execution and improved multitasking. 2. Resource utilization. Data path design can help optimize resource utilization. 3. System responsiveness. A smooth flow of information can lead to the better user experience. Now to the first main question. Why does the data path cycle have a huge influence on the performance of the CPU? The data path cycle significantly influences a CPU because it determines how efficiently the CPU can execute instructions, process data, and interact with other components. The cycle involves data improvement through various subsystems within the CPU, including registers, arithmetic logic unit, ALUs, and memory. Its design impacts performance, power consumption, and overall functionality. Key reasons why the data path cycle influences the CPU. 1. Instruction execution efficiency. The data path cycle defines the steps for fetching, decoding, executing, and storing results. A well-designed data path minimizes the number of cycles needed per instruction. Example, single cycle or pipeline architectures, enhancing performance. 2. Performance, which is clock speed and throughput. The length of the data path determines the clock cycle, which is the time taken for a single operation in the CPU. 3. Pipeline design. Modern CPUs use pipelining, dividing the data path into stages. Example, fetch, decode, execute. Each stage processes different instructions simultaneously. Cycles in the data path directly impact how well instructions can flow through the pipeline, reducing or causing bottlenecks, latency, and bandwidth. The data path cycle influences the latency, which is the time taken for a single instruction, and bandwidth, which is the total instructions processed per unit time. Efficient data paths reduce latency and maximize throughput, improving overall system performance. 5. Power consumption. A longer or inefficient data path cycle requires more clock cycles for execution, increasing power usage. Optimized data paths can reduce power consumption, which are critical for mobile and embedded devices. This diagram indicates the stages of data path cycle. So from the fetch to the decode to the execute and then install. To the next main question: how does a CPU fetch, decode, and execute instructions? The CPU processes instructions in 3 key stages. 1. Fetch. The CPU gets the next instruction from memory. The address of this instruction is held in the program counter (PC). Once fetched, the instruction is stored in the instruction register (IR), and the PC is updated for the next instruction. Decode. The control unit reads the instructions from the IR. It indicates what the instruction is asking the CPU to do. Example: add, move data, or jump. It identifies the operands, data or memory locations involved. And lastly, execute. The operation specified in the instruction is carried out. This may involve arithmetic calculation using the ALU, moving data between memory and registers, or interacting with input or output devices. Results are stored as needed, example, in a register or memory. This fetch, decode, execute cycle is repeated continuously, processing each instruction one at a time or more efficiently with techniques like pipelining in modern CPU. This is the end of the video, and I hope it was helpful. Please like, share, and subscribe for more videos. Thank you.